mag tape or a card reader or something like that. What's that? And IBM provided an operating system called IBSYS that worked on the 7090 to 94. And it was, again, just a basic set of, it didn't take up much memory, less than 8,000 words of memory. And to me, that's one of the biggest problems today. We've gotten so used to enormous amounts of memory that we don't care how big our program is. We just write and write and write and don't worry about it. Okay, this is the I'm sorry?
How does the word, the 80 words or however many words, how does that relate to our bytes?
Okay, most of the machines in this period used words. Byte wasn't a word yet. BYTE wasn't a word. And it did come along later when the 360, IBM 360 machines came along. They started being able to address a single byte, which is 8 characters, 8 bits. And but these machines could only address a word, which was a 36-bit entity. And those words could be a character word, or it could be a single precision floating point number. If you wanted double precision, you had to have 2 of those words to represent the machine, a word like that. This is the console for the 7090 and also the 7094. You can see these little buttons right here. I always was interested. I was at the computer site doing launches frequently, and we had a chief programmer who would sit at this console, and these buttons control what was the primary tracking device at the time. There were several different radars, and so that chief programmer would throw a switch, and that would automatically say, I'm going to use this radar to track the missile, or that one, or that one, or that one. So it was a very human-oriented process. Automatic processes weren't developed. The machine was not a multi-processing machine. It was running one program, and that's all, and a very little bit of an operating system after that. I don't want you to have to read all of this. The 7090 was a nice machine, but it was transistorized. This was the first time we got transistors, and that, of course, reduced the heating requirements and everything else. So that was a very popular machine in the world at that time. Okay, that sort of covers the computers. I've already done the command destruct. Now here's something I really enjoyed doing. Downrange, there were 3 sites which were targeted areas to fire missiles into. There was a short range one at an island called Grand Turk. There was a medium range at Antigua and a long range at Ascension Island. At each of those sites, there were hydrophones, which are represented by these little doohickeys here. These were anchored to the bottom, and there were lines connecting them to a shore station so that an operator or a machinery there could detect when a sound reached that hydrophone and time it very accurately. There was a recording device called a Sanborn recorder, which was a rolling piece of paper with a graphic ink on it. And you could see these signals coming in. Well, when a missile hit the surface, and there were several pieces of a missile that would come down, but the primary one was the one that we're looking. The deal here was they're trying to determine the accuracy of the missiles. How good were they? Were they hitting where they would aim? So anyway, a missile would come in here, impact at this point, and create sound waves which travel in virtually straight lines, not totally straight, but sort of straight lines, from the point on the surface down to the hydrophones. Here's the Grand Turk loop. These were mostly Polaris and early Redstone missiles that flew into Grand Turk. And then for Antigua, they were firing Polaris missiles from the submarines and also from land stations. And then Atlas and the second stage Minuteman rockets flew from Cape Canaveral to Ascension Island, which is about 5,000 miles. So that's where they were at that point. Now, in addition to the underwater sound process that was occurring there, those were straight line sound sources. There was another capability, and it was based on not always this particular one. This is called a SOFAR bomb, and here's the top of it so you can see what size it was. It was only a few inches big. Its purpose was to drop down to a certain level in the ocean. Oh, I forgot the most important one. These bombs were packed in the parachutes of a recovery vehicle, like a Gemini capsule or a Data capsule or an Apollo or whatever. They would pack one of these in with the parachute. So when the parachute was deployed, this bomb would fall out and sink to a pretty low depth in the ocean and explode. And let me go back to that picture. Can you see this little thing with the point on it? That is the firing pin, and it was placed in the top up here. And when the water pressure got to a certain level, it would separate the pin from that ring around it. That pin would then strike a primacord, which was in this part of the missile head, I mean the bomb head, and then there was an explosive in the bottom part. Explosive in here, and then it would explode. So that's the purpose of that SOFAR bomb. Now, why would it do that? What good was it? Well, if you look at the chart of the profile of sound velocity in the ocean, you can see up here it's pretty fast. Notice the speed increases in this direction. So it was pretty fast at the surface, but then as the water temperature got cooler and whatever, it would finally reach a minimum point about here. Oops, backwards, too quick. So this was the minimum velocity of sound in the ocean, and it varies from which ocean you're in and what parts of the ocean. But why is that important? Well, the next slide shows if you explode a sound, or if you make a sound at this point here, the sound waves will be refracted back toward the medium of slowest velocity, so that it will travel thousands of miles without attenuation. It will stay strong the whole time. So those SOFAR bombs were used to locate impacts out in the broad ocean area. You didn't have to hit into a net. You could explode anywhere in the area. There were hydrophones, which were different from the ones on the Mills net. These were located at about 2,000 feet down, or whatever the proper depth was. There was one at Cape Hatteras, another at Grand Turk, Antigua, a place off of Brazil called Fernando de Noronha, Ascension Island, and the Canary Islands. So if a missile or if one of these bombs exploded in here, it could be detected by these hydrophones. And then, by triangulation, we could locate the center. I was happy enough, fortunate enough, whatever you say, to be on board at the time that Gemini 4 was launched and landed here in the middle of the Atlantic at 2744, 7411. And unfortunately, they didn't land where they were supposed to. So we had to know where he was. He wasn't close enough to a tracking ship. So the solution that I came up with the SOFAR bomb timing helped to locate him, but there were some ships close by and they were able to locate him, and here he is being picked up, Gemini 4 recovery. Okay, and that's it for RCA. Any questions there? Okay. Then I went to NASA for a short time. I actually got